Resistance, a potential. So resistors, what are they? What are they going to do for me? Well, from what I've read, it says that resistors create a potential difference or a change in voltage or a use of energy from one point to another. So in other words, you start with 12 volts and go through a resistor and you've got less volts. There is also a current in amps that passes through elements like components such as resistors, and that creates a power and energy, but that doesn't seem to make sense at the moment, so I'll just stick with the voltage, and we'll have a look at the resistors I've got here. I've got 4 resistors here in varying types, and you can get many other resistors and you'll see them all over the place in many different circuits. Open up anything electronic and you'll see resistors in there. A lot of them are really tiny these days, but they are there. So let's have a look at these resistors. Okay, we have 4 resistors here. I'll start with from the right hand side. The first one on the right hand side. Now these are standard resistors. I think both of these are what they call metal film resistors. And there are, I've got 2 there. The one with the brown sort of casing is a 5% tolerance, and the one with the blue casing is a 1% tolerance. And then we've got this big chunky thing here. I think that's a 5% tolerance, but it's a lot more power. And then we've got this big one over here, and that is a 150 ohm resistor, and it's only a 1% tolerance. But it's a big package. Apparently it can take 35 watts. Big chunky thing. Now there is a colour code to resistors I've been looking up, and even though the colour code seems simple enough, trying to remember it, well, I suppose if you do it every single day you're going to remember the colour code. But then of course you've got to be able to see the colours on the resistors. And the difference here is, I'll get this to focus. It looks to me like that's brown, green, brown, and then gold, which tells me that brown being 1, green being 5, brown being 1 again is 151 ohms. But that sounds a bit odd to me, but I can't really see the colours, so sometimes the best way to find out the tolerance, find out the resistance, is to actually get a multimeter and bung that across and have a look. Same goes for the next one along. So this is probably a 1% tolerance, usually because it's a blue casing, but this has got more bands on it. If you can see that, we have 4 bands and 5 bands. And then again you've got to work out the tolerance from and the resistance from the colour code. I always struggle to read the tolerance and resistance or anything else from them, and well, unless you're dealing with something like this big chunky one, that's quite easy. Blue, grey, black and gold, which is a 6, 8 and a 0, so that's a 68 ohm 5% resistor, and judging by the size of it, it's quite a wattage. I think that's a 3 watt resistor. So again, big huge thing. And then at the end there we've got this other resistor, which is 150 ohm 1%, 35 watt, and it's in what they call a TO220 package, and it obviously puts out a lot of heat when you get it up and running in a circuit. So that is something that's for a specialist use, so I probably almost certainly would never be using that in anything unless I've got a specific reason. Quite honestly, I can't think why I bought it. I think I might have bought it because I wanted to create a load resistance, which is something I'm going to at another time. But there you go, so that's a big heavy duty resistor there. Okay, now the thing with resistors is, and any electronics actually, when you're doing electronics, is there's going to be some equations. They're going to tell us how we can use these in the circuit. Now for the most part, that is going to be Ohm's law. So what is Ohm's law? Let's have a look at Ohm's law, right? Now a lot of the time you're going to see it wrote down or written down like this. Where V equals voltage in volts, I equals current in amps, and R equals resistance in ohms, of which the symbol for that is the Greek omega. So from this, what can we do? Well, let's have a look. V equals I times R. So let's take, I know, this, and having a quick look at its colours, I reckon that it's a brown, red, black, and then a brown. That's 1, 2, that's a 1, that's a 2, that's a 0, and then a 1, or is it another black? It's another 1, then I've got a 1, a 2, a 0, and a 1. Now the first 3 bands on this are going to be the value, so that's 120, and then that is the multiplier, so that'll be to the power of 10, so it's 120 times by 10 means that is a 1K2 resistor, because obviously if you times that by 10 you're just going to add another naught on there, so it's 1200, which can be written as 1K2. Learning something all the time, eh? So I've got a 1K2 resistor there. Now I say, well, what can I do with that? Well, another resistance. How much voltage am I going to put in? Well, okay, I'm going to say I know that, so how can I rearrange this thing now to give me the current? Going back to this, when you rearrange it, we end up with I equals V divided by R, because I'm going to say that I'm going to put 12 volts into this, 12 volts, and I've got a 1K2 ohm resistor. So now I'm going to find out how much current this resistor can deal with. So we're going to say 12 divided by 1200. Well, what's that? Let's get the old calculator. So we got 12 divided by 1200 equals, it's telling me I'm going to have 0.01 amps equals 0.01 amps, or we can write that as 10 milliamps. That's a really small current, so looking at that you go, well, it's not going to do much. Well, it does, I suppose. It gives you 10 milliamps of current, which for small electronic circuits is perfectly good. What about this big thing then? We worked out earlier that this is a 68 ohm. So if I've got 12 volts and 68 ohms, also written as R, that just confused me. So let's write that down. Let's find out what the current this can deal with. So we've got 12 divided by 68. 12 divided by 68 gives me 176, 0.176 amps, or 176 milliamps. So that can handle a bit more current. Now, there's another thing that goes with the current and voltage, and that's power. Now, apparently, if you put too much current through the resistor, it'll end up toast. So we need to be able to know what sort of current is going to go through the resistor and whether that resistor can handle it. And they all have a rating. Like I said before, these are probably, this one's probably a 3 watt. Now these little ones are almost certainly going to be 1/4 watt. That's a 1/4 of a watt of power they can dissipate. Or is that energy? There's a confusion. So, power. Power over IV. What does that mean? So, guys, see that? That means power measured in watts. Okay. So I'm saying here I've got power equals current times by voltage. Well, that's not too bad. I've already calculated over here my current and I know the voltage, so it should be quite easy to find out the power. So I can say, let's take that from the first one where I said it's 10 milliamps or 0.01 amp and 12 volts. So 0.01 amps times by 12 volts. 0.01 times by 12, and that equals 0.12 watts. And we know that these are a 1/4 watt resistor. That's less than a 1/4 watt. That's more like 1/8 of a watt. So brilliant, that can handle it. What about the bigger one, the 68 ohm resistor? So from that it told us that we've got 176 milliamps. So that's 0.176 amps times by that 12 volts. 0.176 times by 12 gives me 2.112 watts. We just round that up to 2 watts. Marvellous. That's great, because when I got this it told me it's a 3 watt resistor. So both of these resistors, if they were connected up to a 12 volt supply, could very easily deal with the wattage rating or the power rating for each resistor. I'm not going to do the 35 watt one. I certainly don't have a power supply that's going to get that hot. Now I think about time I connected a couple of these up, and we'll have a look at what that maths is telling us, if we're correct, if I've done it right, if I've understood the maths that relates to the current and the power. I don't have a meter that can show me the power, but I can show you the voltage and the current, which is what I'm going to do next. Okay, and just to show you that these resistors are what I think they are, this one is 1198 ohms, so 1K2, as I'd said earlier. What about the others? Let's have a quick look. Take this other little one, not quite sure what that is. Got my multimeter, and that is 148 ohm. There's a green in there, so I said that was there was a brown that's 1, green that's 5, and a brown that is 1, or it could be a black. So if that's a black, that would be a 1, a 5 and a 0. 150 ohm resistor. And considering there's always a discrepancy in that, because these have a tolerance of 1 or 5% or whatever that tolerance might be, 148 ohms, perfectly fine. And let's have a quick look at this big one here. Oh, look at that, let's take it down a range. That's telling me it is at that settle. Let's just take that off a minute. Connect it back up and let it settle. Now that's telling me it is 70.8 ohms. It says it's a 68 ohm resistor. It's got a 5% tolerance, so 70 ohms, yeah, that's fine with me. Okay, here we have the little circuit setup. What I've done is basically the power comes into this multimeter. It's just going to read the current, so it goes in here, comes out, goes round to the resistor, out the resistor to the power, and this one is going across the resistor so we can see the voltage. So what are we expecting? What am I expecting? Well, I'm expecting it's going to tell me it's got 12 volts across there, and it's got 10 milliamps. Now you can see it, this is on the 20 milliamp range, so I'm expecting that to say 10, and this is on the 20 volts range, so I'm expecting 12 volts from there. So let's turn it on and see if I've got this right. Well, there you go, story told. 12 volts across the resistor, 10 milliamps, which means that I have 0.12 watts, so just under an eighth of a watt of power through a quarter watt resistor. That's what it's doing. I've got 10 milliamps, 12 volts, and a quarter watt resistor, a 1K2 quarter watt resistor, and it's fine. So let's hook up another resistor, see what that does. What about that big chunky one that I had? This which actually is 70 ohm according to the multimeter when I've checked it. So let's have a look at that. Turn the power off. Let's connect the voltage meter first. Let's connect the other meter, so to measure the current across there. I should say the current through it. Now that's the thing as well with these, they say there's a certain format to describing the way the voltage and current is. The voltage is across, because when you measure it, you measure across the resistor, and the current goes through the resistor, so, or through the component, so that's a flow of current through. So it's a sort of terminology you're sort of expected to use correctly. Now the other thing with this is, what have I got to set this meter to? When I measured it before, when I calculated it, sorry, I calculated 176 milliamps. So I'm going to have to change the setting for that meter up a range. So let's turn it on and see if I've got 12 volts, 176 milliamps. Oh, you look at that. Okay, this says 11.79 volts. That's okay, it's almost 12 volts. And this says 176 milliamps. It's fluctuating about a bit there. Probably as this resistor warms up, and it will warm up, but we calculated that it's going to be able to handle 2 watts, which is what it's going to create with the current that's flowing through it. It's a 3 watt resistor, not a problem. It's going to work fine. We're not going to have a problem with that. So what have I done today? What have I learnt today? I've got Ohm's law, I've got power law, is it? I presume that's what it is. And I've calculated the current and the power for these 2 resistors, and then I've connected them up and proved that that's right. So it's like I'm on a winner. Can't go wrong there, can we?